This is a hedgehog, a predator so successful that it has conquered almost every corner of the old world. They are renowned for their impenetrable defenses, venom tolerance, and extreme hibernation, which makes them one of the most geniusly adapted animals on the planet. But what if I told you that this isn't a hedgehog at all, and neither is this, or this? It turns out that many animals who look and act like hedgehogs aren't really hedgehogs at all. In parts of the world where hedgehogs were unable to reach, completely unrelated animals took their place in a phenomenon known as convergent evolution. The Americas, Africa, Australia, the Middle East, and perhaps even New Zealand have all given rise to mimics of the hedgehog, some of which evolved to such a degree that they are indistinguishable from the real thing. So why do animals keep evolving into hedgehogs? In this video, we'll finally answer that question. But before we look at each of the copycats, we first need to know where the original came from. And for a long time, scientists were completely wrong about their origin. Until the 1990s, hedgehogs were thrown into a wastebasket group, known as Insectivora. Basically, if you were a small, bug-eating mammal that didn't fit anywhere else, you went in there. But when modern genetics was first used to study how different mammals were related to each other, Insectivora was ripped apart. As it turned out, many of the insectivorans were not related whatsoever. Most of them were placed into the brand new order Afrotheria, alongside elephants and the aardvark, whilst the tree shrews and colagoose were moved closer to the rodents and primates. The remaining species, such as moles, shrews, and hedgehogs, were found to be more closely related to each other than to any other mammals, and were renamed the Eulipotifla. Eulipotiflans are a truly ancient group of creatures, and they began to diversify before the end Cretaceous extinction that wiped out the non-avian dinosaurs. Hedgehog-like creatures first appeared in the fossil record around 35 million years ago, and they already had many of the characteristics of modern hedgehogs. However, their rise to dominance took some time. Likely originating in Europe, they slowly spread out and conquered the old world, even reaching North America during their peak. And in order to conquer the world, hedgehogs developed a set of crucial adaptations. This incredible design is the reason so many other creatures around the globe have copied them, with by far their most important asset being their armor. Made up of over 5,000 spines, it evolved over time from hair, eventually becoming almost indestructible. And when they curl up to hide their underside and face, they are immune to all but the most skillful predators. Combine this with a set of ultra-sharp teeth, tolerance to snake venom, an excellent sense of smell, the ability to withstand some of the most brutal conditions on Earth by entering torpor, and you have a blueprint so effective that evolution decided to use it more than once. And no animal has this blueprint been applied more than in tenrecs. Looking at some of the most convergent species, such as the lesser hedgehog tenrec, you'd be forgiven for thinking they were hedgehogs. But as a whole, tenrecs are far more diverse, with no two genuses looking alike. There are the shrew tenrecs, the large-eared tenrec, the nesogale tenrecs, the rice tenrecs, the greater and lesser hedgehog tenrecs, the common tenrecs, and the bizarre streaked tenrec, which is no doubt one of the weirdest creatures on Earth. Of these, the largest are the common tenrecs, which reach 39 centimeters and 1 kilogram, whilst the smallest are truly tiny, coming in at just 4.5 centimeters and 5 grams. But despite the differences, they do share some common traits. Oddly, all species are able to echolocate, have low body temperatures, and lack scrotums. However, just like hedgehogs, they are omnivores, have highly sensitive whiskers, are primarily nocturnal, have spines, and a very similar build. Which is so surprising, given that they could hardly be further separated from the Eulipotiflans, with the two groups having split more than 90 million years ago. So what exactly are tenrecs? Well, they are Afrotherians, members of the same order as other African mammals, such as hyraxes and elephants. This group first appeared right after Africa and South America broke away from each other, leaving Africa on its own. This isolation meant that the niches usually occupied by other more widespread kinds of animals were filled by this more primitive group. Within the Afrotheria tenrecs are nested in a clade called Afroinsectivora, with their closest living relative being the otter shrews. However, whilst all other Afrotherians are native to the African mainland, the tenrecs are exclusive to Madagascar. So how and when did they get there? Well, thanks to genetics, we know that all living tenrecs descend from just a single species, which colonized Madagascar between 42 and 25 million years ago. They were probably swept out to sea during a storm, with their low metabolisms allowing them to survive the journey. Such events are extremely rare, but given the timescale, the chances weren't exactly slim. At the time, the only mammalian inhabitants were bats, and of course lemurs. And so when the tenrecs arrived, they rapidly diversified to fill the niche of small omnivores. We know they didn't evolve on the island itself, as fossil evidence shows they were previously widespread on the mainland too, especially during the Miocene. And later in this video, we'll get to the reason they disappeared. But first, we need to divert our attention to perhaps the strangest animal to have converged with hedgehogs. It's called the echidna, and it inhabits parts of Australia and New Guinea, which were connected as recently as 8,000 years ago. Most people know that due to its remote location, Australasia is the only continent where marsupial mammals remain the majority. However, before their arrival 50 million years ago, an even more primitive branch of mammals called Australia home, the monotremes. The echidna and platypus represent the two final branches of this ancient line that diverged from other mammals roughly 200 million years ago, and as a result, they retain many primitive features unique among mammals. For example, adults lack teeth, possess echolocation, and most notably, monotremes lay eggs. Yet despite the deep history of monotremes, echidnas themselves are a relatively new addition to the tree of life. The earliest fossils don't appear until the Pliocene. Although it may sound odd, it is actually the ancient origin of monotremes that made it possible for echidnas to converge with hedgehogs. That's because they have far lower metabolic rates than any other kind of mammal, which meant that evolving to outrun predators was simply not an option. Their spines, which are far larger than any other creature we've covered so far, were essential to compete with the more advanced marsupials. This is backed up by the fact their closest relative, the platypus, occupies the aquatic invertebrate hunter niche, in which a monotreme would have an advantage. In fact, echidnas likely evolved from aquatic ancestors, which we can see in its morphology adapted for hydrodynamism. However, their adaptations do differ from hedgehogs in one crucial way. They are adapted for termite and earthworm specialist diets. As a result, they evolved much longer snouts for probing, in an adaptation many have compared to anteaters. But out of all the spined animals, porcupines have taken it to the most extreme. In the largest species, their quills can grow to 35 centimeters, which, as you can imagine, would be pretty painful to try and eat. Porcupines form two families, the Old and New World porcupines, and are rodents. The Old World porcupines are much larger than their cousins, and are nocturnal ground-dwelling animals, whilst the New World porcupines are largely arboreal, and are often active during the day. But the strange thing is that porcupines don't really exist, as the two different families are not close relatives. In fact, the New World porcupines are much more closely related to the capybara and degu than they are to the Old World porcupines, who they split from as early as 37.2 million years ago. This means that either family evolved their spines independently. Regardless, both evolved spines for the same reason. As fairly large animals, with some weighing up to 30 kilograms, they couldn't simply evolve to run away or hide from predators. Unlike all other animals with spines, those of porcupines are not permanently attached and will stick to predators who try to eat them. This leaves the predator in a huge amount of pain and serves as a lifelong reminder to never try and eat one again. But the similarities with hedgehogs end with its defenses, as since porcupines are strict herbivores, the face is much flatter, and the teeth are not sharp and conical. All the animals we've covered up to this point have developed complete spines after millions of years of evolution. It's easy to see that having a full set of armor is beneficial, but for an incredibly long time, that armor would have been weak and incomplete. So, to get an idea of how they began to evolve, we need to find a group of animals that is undergoing that transition right now. And believe it or not, there is one group of animals that this has actually happened to: the spiny mice. At first glance, they might just seem like any other kind of rodent, but look close, and you can see that they are covered in a coat of fairly sparse, hardened hairs. Along with this, they are the only mammal able to automatically release skin when being attacked by predators, a trait often seen in lizards. And like their reptilian cousins, this skin can be fully regenerated. Whilst their spines don't make it harder for predators to eat them, they do make it very unpleasant, giving the individuals with spinier hair more time to escape. Even an imperceptible difference can trigger a change over long time frames. As inhabitants of dry environments, they have fewer places to hide, and thus there is a much stronger pressure to evolve this kind of adaptation. Today, they comprise a few dozen species belonging to the genus Acamis, and although they likely originated in the Mediterranean, they have managed to spread to southern Africa. Given enough time, it's almost certain that the spiny mice would keep developing more advanced spines. With that being said, are there any other animals that could go down a similar path? Well, to me, one creature stands out as having the ability to evolve complex spines deep into the future. And although it might surprise you, that animal is not a mammal, it's the kiwi. Since the only native mammals in New Zealand are bats, it was birds that filled most of the empty niches here. The kiwi lost its flight, evolved a long beak, and the best sense of smell of all birds. It also developed a very dense and short plumage, which resembles a mammal's fur. Interestingly, the plumage is already fairly spiny, but with a lack of mammalian predators, there was little need to develop defenses. This changed after the arrival of humans who brought over all kinds of invasive species, which devastated the local fauna, including kiwis, which could theoretically put enough pressure on kiwis to develop spines over the next few million years, though this is a bit of a stretch. Thanks for watching. I hope you enjoyed.